Hi there, future scientists and math wizards. Welcome to Smile Road. I'm Sir M, and I created this channel just for you, senior high school students looking to make science and math easier, clearer, and yes, even more fun. On Smile Road, we explore exciting lessons in general science, solve real life problems in general mathematics, and learn how these subjects connect to the world around us, from floating boats to your monthly budget. Each meeting, I'll guide you through lessons using simple explanations, real life examples, and even a few challenges to keep your brain sharp. Whether you're reviewing for exams, catching up on class topics, or just curious about how the world works, you're in the right place. Don't forget to hit that like, subscribe, and notification bell so you won't miss any of our learning adventures here on Smile Road. So, are you ready to start this journey with me? Let's walk the road of knowledge with a smile. Our topic for today is about using functions to model and solve real life problems. And then this is quarter two of general mathematics about numbers and algebra. Once again, we are dealing with quarter two, numbers and algebra, lesson 11, using functions to model and solve real-life problems. Our intended learning outcomes. At the end of the lesson, the learners will be able to A. Recognize situations in real life where mathematical functions can be applied. Letter B. Translate real-life problems into appropriate mathematical functions, linear, quadratic, exponential, logarithmic, piecewise, etc. And then letter C, solve problems by applying functions to model practical contexts. Letter D, interpret and evaluate the results within the context of the real life situation. Letter E, communicate solutions clearly through written explanations, graphs, and numerical results. Functions as models of real-life situations. Functions are not just abstract mathematical tools. They describe how quantities relate to each other in the real world. A function shows the relationship between an independent variable, which is the input, and a dependent variable, which is the output. Examples: the distance traveled depends on the speed and time, and of course, the distance traveled is the output, and the speed and time would be the inputs. The price paid at the grocery store depends on the number of items bought. Population growth depends on time, often modeled with exponential functions. Mathematical functions help us understand the behavior of systems, predict outcomes, optimize resources, and decisions. Number two, types of functions in real-life applications. We have linear functions, represent constant rates of change. Example, taxi fare that changes a base fee plus a fixed rate per kilometer. Quadratic functions represent parabolic relationships, often involving maximum or minimum values. Example, the path of a ball thrown into the air, profit maximization in business. And then exponential functions represents rapid growth or decay. Example, population growth, spread of viruses, compound interest. Logarithmic functions represent slow growth after rapid increases. Example, pH in chemistry, Richter scale for earthquakes, decibel levels in sound. Piecewise functions represent different rules for different conditions. Example, electricity bill with shared pricing, income tax brackets, and steps in applying functions to real life problems. First, you need to understand the context. Read the problem carefully. Identify what is changing, which is the independent variable, and what is being measured, the dependent variable. And then translate into a mathematical function. Choose the type of function that best models the situation. Is it linear? Is it quadratic? Or any other function? And then solve using the function. You need to plug in the values, do the computation, or use algebraic manipulations. And then graph for better understanding. Use graphing tools to illustrate the relationship visually. And then interpret the results. Translate the mathematical answer back into the real world meaning. Examples of real-life applications. Purchasing. If apples cost 50 pesos per kilo, then the cost as a function of kilograms x is C, a function of x equals to 50 times x. So, in the income tax, a tax system where 10% is charged on the first 20,000 income and 20% on the rest can be expressed as a piecewise function. So, business profits. If profit depends on how many products are sold, a quadratic function may describe revenue versus cost. And in science, radioactive decay is modeled using exponential functions. In engineering, the stress-strain relationships may be modeled using polynomial or exponential functions. Importance of applying functions in decision making. It helps businesses decide pricing, production, and resource allocation. Forecasting predicts future outcomes. Example, weather, population, demand. And then we have problem solving. Provide systematic methods to tackle complex situations. In visualization, graphs help us see patterns and relationships at a glance. And then we have here the practice problems for quarter 2, numbers, and algebra lesson 11 using functions to model and solve real-life problems. Practice problem number 1. The population of a bacteria culture doubles every 4 hours. If the initial population is 500, model the population size as a function of time in hours. So we're given population doubles every 4 hours. initial population 500. So we are required to model the population P as a function of T, and the T is in hours. So our solution will be exponential growth with factor 2 every 4 hours. So the growth per hour factor is 2 raised to 1 fourth. And the standard form will be I population P as a function of time is equal to 500 times 2 raised to T over 4. So our final answer will be population a function of time is equals to 500 times 2 raised to T over 4. And then practice problem number 2. The revenue of a company can be modeled as R a function of X is equal to 50X minus 200, where X is the number of units sold. Interpret the function in real-life context. So we're given a revenue function. R, a function of X, is equals to 50X minus 200. And X is the unit sold. So we are required to interpret that in real life. So solution, 50X is revenue per unit, say 50 pesos per unit, minus 200 is a fixed cost or set up expense subtracted from gross revenue. So, net revenue is equal to the net income minus the fixed cost. So, the final answer, for every unit sold, the company earns 50 pesos after selling X units. Um, Total revenue is 50 pesos multiplied by X. And after covering fixed expenses, 200 pesos, the net revenue is 50x minus 200. Let's have practice number 3. A car depreciates in value according to the function V, a function of T, is equal to 800,000 times 0.85 raised to T, where T is the number of years after 4 chess. So model and interpret the value of the car after 5 years. So we're given the value of the car, which is V, a function of T, is equal to 800,000 times 0.85 raised to T with T in years. So required value after 5 years and interpretation. So our solution, compute for B a function of 5. So substitute 5 in the equation. So we have 800,000 times 0.85 raised to the 5, and that is equivalent to 354,964 pesos and 25 centavos. So the final answer for our B, a function of T, equal to 800,000 times 0.85 T. Our, the value after 5 years of the car is 354,964 pesos and 25 centavos. So, interpretation, the car retains about 354,964 after 5 years. We will have the next part of this lesson, quarter 2, numbers and algebra, lesson 11.